Hi guys, so in the part 2 of this video, we are going to look into more detail or more examples on how we can apply equilibrium in a coplanar system. Actually, you guys dah buat pun the equilibrium in coplanar system from the exercise in the previous video. But now I'm just going to give you a different example so that you can strengthen your understanding on applying equilibrium condition. So in many engineering applications, a body or an object is being subjected to many different forces. So the forces can be senget-benget like this. So when the force is senget-benget, it's going to be very difficult for you to analyze the system in terms of the reactive force. So it is more convenient if you can resolve or convert that forces into a direction which is easier for us to analyze, which is in the x and y direction. When you apply the equilibrium condition in coplanar plane, it means that you assume that all the forces in x direction is equals to 0 and also all the forces in y direction is also equivalent to 0. Let's look at this example. In this example, given that the lamp of 8 kg is being held together by a spring and also a cord AC. So, the question asks you to find what is the length of cord AC so that the lamp is suspended. Lamp is suspended means that lampu tu tergantung je macam tu. It doesn't slide or it doesn't move. So, in other words, we wanted to know what is the length of the cord when the whole system is in equilibrium. Let us jot down the important information. We know the mass of the lamp is 8 kg. They want us to find what is the length of cord AC, and given that the original length of the spring, or I'll call it LAB naught, is equivalent to 0.4 meter. So also given is a spring stiffness of 300 Newton meter. The lamp, the spring, and also cord AC is being connected at point A. So let us free up this particular point and draw the free body diagram. By focusing at point A, then we can find all the magnitude and direction of the forces acting at node A. So this is our point A. It is connected to the lamp. So that is the weight of the lamp acting at this particular cable. So point A is also connected with the spring of AB. So let's call the tension force acting at the spring to be FAB. And then point A is also connected to cord AC. So we'll call the tension force at cord AC to be FAC. The weight of the lamp and also the force at the spring AB is okay, no problem, because it is in a planar system whereby weight of the lamp is at the y direction and then the FAB is at the x direction. Masalahnya sekarang is at the cord AC. Dia senget kan macam tu. So in order to simplify your free body diagram, you have to convert or resolve the FAC into an equivalent force at the x direction and also an equivalent force at the y direction. So we know the angle between cord AC and the x direction is 30 degree. So you can calculate the magnitude of the force along the x direction to be FAC multiplied with cos 30. The magnitude of force AC along the y direction pula can be calculated using formula FAC sin 30. Okay, now barulah you boleh buat the equilibrium analysis along either the x and y direction. Okay, kita buat along the x direction dulu. So, assuming the direction on the right is positive, so by right, summation of all forces in x direction should be equivalent to 0. So, what are the forces happening at the x direction? The first one is force AB. It is positive because it is pointed to the right. And then the second force is FAC cos 30. And it is negative because the force is pointed to the left. Ada lagi tak forces at the x direction? Tak ada. So, kita sum up these two forces to be equivalent to 0. So, there are two unknowns in this equation, which is FAB and FAC. Kita tak boleh nak solve apa-apa pun. So, let's just leave it as it is and let's call this equation to be equation 1. Now let's apply the equilibrium condition in the y direction pula. So assuming the upward direction to be positive, then summation of all forces in y direction should be equivalent to 0. So what are the forces happening along the y direction? Okay, the first one is the weight of the lamp. So sekarang ni notice the direction of the weight is downward. So the magnitude would be negative W. And then the second force is the FAC sin 30 and the direction is upward. So that is why the magnitude becomes positive. Ada lagi tak forces happening along the y direction? Tak ada. So we sum up these two forces to be equivalent to 0. The weight can be calculated using the formula mg. And then the remaining expression tu, kita tak tahu, kita just use it as it is. Mass of the lamp is given to be 8 kg and the g value is a standard value of gravitational acceleration which is 9.81. So this equation cuma tinggal satu unknown sahaja which is the FAC. So you can actually solve it for FAC. Negative 8 times 9.81 bawa ke kanan jadi positive and then you have to divide it with sin 30 and you will get your final value of force along the AC cable to be 156.96. Check the unit that you should use and it would be in Newton. I'm going to call this relationship as equation 2. Now you can solve for equation 1 by substituting the value of equation 2 into equation 1. Okay, FAB is still unknown and then tolak dengan FAC. Tadi kita dah kira the value is 156.96 multiplied with cos 30 would be equivalent to 0. So now your equation only have one unknown which is the FAB. So boleh solve tak? Boleh. It's quite straightforward. Okay, you bring the whole expression over here to the right and you will get a corresponding value of force along AB direction to be 135.93 Newton. Now that we know all the reactive forces happening at North Sea, so why don't we further analyze this problem? So the only information given in this question is related to the spring constant and also the original length of the spring. So let us further analyze the spring. This is how the spring system looks like and this is the free body diagram. There are tension force acting on the left and the right side of the spring and the force is FAB. If you recall the basic spring formula masa kelas fizik zaman dulu, okay, the force at the spring is equivalent to Kx, whereby x is the elongation of the spring when it is being subjected to external load and K is the constant of the spring. So kita rename this equation and we know the force at the spring is FAB and then we know the constant of the spring, we call it KAB and there's an elongation value over here. FAB tadi kita dah kira which is 135.93 Newton and then the constant of the spring is already given in the question which is 300 Newton meter and then we can calculate the elongation of the spring when it is subjected to load. So we arrange the equation and our x would be 0.4531 meter. Unit dia is in meter lah because it's an elongation quantity. So kalau kita tengok the logic behind the elongation formula, so basically the total new length of the spring is equivalent to the original length plus with the elongation or the x yang kita dapat tadi. Original length of the spring is already given in the question whereby they say that the original length of the spring is 0.4 meter and the elongation is 0.4531. So we substitute these two values into our equation and we will get the new length of the spring to be 0.853 meter. So this length is the new length after force is applied to it. Ataupun dalam arti kata lain, this is the new length of the spring when the lamp is being held in equilibrium. Okay, let me just paste the image on this worksheet so that it is easier for us to refer for our calculation. So, the new length is calculated to be 0.853 meter. And then kita tahu the horizontal length from point C to point B is 2 meter. So, boleh tak kita kira the horizontal length from point C to point A? Boleh lah kan, you simply tolak 2 meter dengan the new length of the spring which is 0.853 meter. So the length of AC in X direction would be 1.147 meter. Tapi soalan minta kita the length of the chord AC. So basically kita try keluarkan this triangle over here. I think you should get the idea by now. So with this triangle, you can actually use the trigonometric relationship. So we know the length at this point is 1.147 meter, and the length that we want to calculate is the length AC over here. And we know the angle 30 degrees over here. So using the trigonometric relationship, you can use the cosine equation, whereby cos 30 is equivalent to 1.147 meter divided with the hypotenuse, which is the length of AC. So you can rearrange the equation and you can calculate the length of chord AC to be 1.3244 meter. Okay, dah dapat jawapan. Oh, please notice saya ada tersilap tulis dalam my slide over here. So the LAB should be replaced with LAC. So anyway, I hope this helps you in understanding the equilibrium in 2D coplanar system. So next up, we will look into the equilibrium along the 3D system.